Hello, my dear friends. Welcome to class 9. I am Soham Jagat. In the last lecture, we have seen what is colloidal solution or what is colloids. We have seen that if we put if we take water and mixed in it chalk powder or wheat flour, the kind of mixture we have, that is suspension. After that, we have seen if we take water and drops of water, add drops of milk in it, we get a mixture that is kind of colloidal solution. Or if we take only milk, that is also the example of colloidal solution. So we have seen some basic property of colloidal solution. For example, the particles of colloid are uniformly spread throughout the solution, which means if you put the drops of milk in water and stir it, the milk particles and other particles that is in milk are spread uniformly throughout the solution. Due to the relative smaller size of particle as compared to suspension, they are uniformly distributed because particle size is relatively larger or relatively smaller. I would say relatively smaller compared to suspension, and the particle size is comparatively larger with respect to solution. So the particle size of colloidal solution is larger than solution but smaller than suspension. The mixture appear to be homogeneous, but actually colloidal solution is heterogeneous mixture, as we have seen. For example, milk, which means that colloidal solution are looks like homogeneous, but actually they are heterogeneous. These particles can easily scatter the beam of visible light, as we have seen that if we pass light beam through it, the path of light beam we can see, as we can see in here figure, that we can see the path of light. So that scattering of beam of light is called Tyndall effect. We have seen that the scattering of light is called Tyndall effect. Tyndall effect can be observed when fine beam of light enters the room through a small hole. We have seen example of Tyndall effect with images. So where we can see the Tyndall effect. So here we have another example when light enters in the room, in the dark room, from the fine hole. At that time we can see the particles that present in air, that is the particles of dust and smoke, act as a colloidal solution, and it scattered the beam of light, and hence we can see the beam of light, the path of beam of light. Another example, we have seen that Tyndall effect can be observed when sunlight passes through the canopy of dense forest. So in dense forest also we can see the Tyndall effect. We have seen photographs of it also. Also we have here one photograph of Tyndall effect. You can see here the dense forest and the sun rays are coming from sky and which appears here inside the forest. After that, we have properties of colloids. So we have to remember only the noted or marked point. You can observe as I read that is meaningful, although I read only a marked point. Properties of colloid: heterogeneous mixture, which means colloids are heterogeneous mixture. Size too small to be individually seen by naked eyes, which means the particles of colloid cannot be seen by naked eyes. Big enough to scatter the beam of light passing through it and make its path visible, which means colloid particles are large enough, big enough that can scatter the path of light beam, so we can see the path of light beam passing through colloids. Do not settle down, colloid is quite stable. When we left the colloidal solution for few hours or few minutes, it will not settle down. It means colloid is quite stable. So these are some properties of colloidal solution. After that, we have one important property. It cannot be separated from mixture by process of filtration. As we have seen that suspension can be separated by filtration. Solution cannot be separated by filtration. Here, colloidal solution also cannot be separated by process, that is filtration. But we have special technique of separation known as centrifugation. This centrifugation process can separate colloidal particles. The component of colloid solution are two: dispersed phase and dispersion medium. As we have seen yesterday, there are two components of solution, that is solute and solvent. Similarly, here we have two components of colloidal solution, that is dispersed phase and dispersion medium. So we have two components, dispersed phase and dispersion medium. We can compare this dispersed phase and dispersion medium with solute and solvent. Here dispersed phase is like solute, which means this is which dissolved, or here in case we can say mixed with dispersion medium. So dispersion medium is always in larger quantity while dispersed phase is in lesser quantity, which add or mixed into dispersion medium. So the solute-like component or the dispersed particle in the colloid form the dispersed phase. So the dispersed phase we can compare with solute, and it is the dispersed particles, and the component in which dispersed phase is suspended is known as dispersing medium. Here you will remember this word suspended, because in exam you have to write this proper words called suspended. Component in which dispersed phase is suspended is known as dispersed medium. Colloids are classified according to their state, as we have seen solid, liquid and gas. Here we have some example of commonly known colloids, or we can say basic example of colloids. Fog, cloud or mist, that is the example of colloid, but this is we called as aerosol. Why? Because gas as dispersing medium and liquid is dispersed phase, which means liquid in gas type colloidal solution. So gas in larger quantity, which means that is called aerosol. So fog, cloud, mist are the example of colloidal solution. This type is aerosol colloids and this is liquid in gas type colloids, that is called aerosol. Another example is smoke, automobile exhaust, that is also called aerosol, in which we have dispersed phases liquid, which means solid, which means solid in gas type of colloidal solution. So that two example we have familiar with. Another example is shaving cream. Here you can see in first two cases we have dispersing medium as a gas. Gas as dispersing medium and dispersed phase is liquid and solid respectively, and that is called aerosol. Now we have dispersing medium as liquid. Liquid as dispersing medium. So here we have three cases: gas in liquid, liquid in liquid and solid in liquid. So here we have first case, gas in liquid. Gas in liquid, that we call as foam, and the example of foam is shaving cream. We have also now a foam kind of shaving foam that we call as foam only. You have seen one container cylindrical which we use after shaking it, and we push the button and the foam came out. So that is what we call as foam. That is nothing but colloidal solution, that is gas in liquid type of colloidal solution we call as foam, and example is shaving cream. After that we have liquid in liquid type of colloidal solution, that is called emulsion. You might heard this word emulsion. Emulsion is nothing but the colloidal solution in which liquid is as dispersing medium and liquid as dispersed phase. So this is liquid in liquid type of colloidal solution, and the examples are milk, face cream, etc. So the milk and face cream are the example of emulsion, which is liquid in liquid type of colloidal solution. After that we have solid in liquid type of colloidal solution, which we called as sol, and the example of sol is milk of magnesia and mud, which means dispersing medium as a liquid and in which we have solid particles as a dispersed phase. So solid in liquid type of colloidal solution known as sol, and the examples are milk of magnesia and mud. After that we have another type, that is also foam. Now we have dispersing medium as solid, and similarly as we have seen earlier in liquid case, we have three different dispersed phase, that is gas, liquid and solid. Gas in solid, liquid in solid and solid in solid. So first example is gas in solid. So gas in solid we called as foam, and the example is foam, rubber, sponge, pumice, that are the example of colloids type form, that is gas in solid. You can easily understand foam and sponge example. Let's take example of sponge. You can see the structure of sponge in which there are tiny holes and these holes contain air. When we press it, air releases and this hole contracts. So we can push it or we can compress it. So that is example of foam, which means gas in solid kind of colloidal solution. After that we have liquid in solid type of solution, which means solid as dispersing medium and liquid as dispersed phase, that is gel. So jelly, cheese, butter are gel type of colloidal solution, that is liquid in solid type of colloidal solution. Gel as a type of colloidal solution, dispersing medium as a solid, dispersed phase is liquid, and examples are jelly, cheese, butter, etc. After that we have solid in solid type of example, that is what we call as solid sol. Solid sol. Colored gemstone, milky glass are the example of solid sol in which dispersing medium and dispersed phase are solid, which means in solid we have to add solid. So that is called solid sol, an example of colored gemstone and milky glass. So these are some important example of colloidal solution. These are its type and respective dispersing medium and dispersing phase. We have to remember this chart. This is important for 1 marks question. So try to remember this chart. This is not as difficult if you remember it by some technique or by simplifying it this chart, so you can remember it. Now we have seen three basic type of mixture, that is suspension, solution and colloidal solution or colloid. Let's see the difference in both three or compare these three. Let's see the difference or comparison between solution, colloidal solution and suspension. By various property, we will see the difference or comparison between this true solution, colloidal solution and suspension. First point of comparison is size particles. Size of particles. You can see and you can remember that the solution has a least size of particles. After that colloidal solution, and after that suspension has the largest size of particles among these three. So here you can see that particle size is less than 10 raised to minus 9 meter, that is 1 nanometer. Between range of 10 raised to minus 9 to 10 raised to minus 6 meter, so that is micrometer. 10 raised to minus 9, that is nanometer. 10 raised to minus 6, that is micrometer. 10 raised to minus 6 meter is 1 micrometer. And here you can see the suspension size, particle size is more than 1 micrometer. So that is about particle size. You can remember particle size as least size in solution, colloidal solution, suspension. It means size is increasing from solution to colloidal solution to suspension. Size is increasing. Nature. true solution is homogeneous, which means particles are distributed evenly throughout the solution. Colloidal solutions are appears homogeneous, but it is actually heterogeneous. Colloidal solution are appears homogeneous, but actually they are heterogeneous. Suspension clearly heterogeneous. So you can remember homogeneous, heterogeneous, heterogeneous. That is about nature of solution. Visibility. Can we visible the particles of any mixture? The solution particle are invisible to naked eye and also under microscope. So the particles of solution we cannot see with naked eyes, and also sometimes we cannot see under microscope also. Whereas colloidal solution, the particle size is increased little bit, but also we cannot see by naked eyes. So here second point you can see that the solute particles are invisible to naked eye but can be viewed under powerful microscope. If you have powerful microscope, then you can see the solute particles. Solute particles means here dispersing phase. So we can see dispersed phase in colloidal solution with powerful microscope. And the particle size is relatively larger in suspension, so particles of suspension we can see with naked eyes. So that is about the visibility of particles, that is according to true solution, colloidal solution and suspension. After that we have next comparison point as stability. Stability, which means can given mixture remains stable or not. In properties, we have seen that the solute particles do not settle down and are stable, which means the solution is stable. Colloidal solution. In colloidal solution also, particles do not settle down, which means colloidal solution is also quite stable. But in suspension, we have seen in property itself that if you leave it for few hours or few minutes depending upon the mixture, suspended particles can be settled down easily. So here the suspension is unstable. Suspension is unstable because the solute particle settle down. Filtration as the next comparison point, which means with the help of filtration can you separate the particles that is mixed in this mixture. So that is the next point of comparison, that is filtration. Let's see the filtration in solution. The solute particles can be passed through filter paper and no residue is seen on the filter paper. All the particles, solute and solvent, pass through the filter paper, hence solution cannot be filtered or cannot be separated by filtration process. Solute particle also passes in case of colloidal solution. Hence, we cannot separate colloidal solution from filtration process. But the particles cannot pass through parchment membrane. We will not bother about this parchment membrane at this point of time. You will remember only first sentence, that is pass through the filter paper and no residue is left, which means it cannot be separated by process of filtration. But here in suspension the particle size are relatively larger, so we can separate it easily with the process of filtration. So that is about filtration process. Solution cannot be filtered or separate. Colloidal solution also cannot be separate, but suspension we can separate with the help of filtration process. After that, we have a comparison point as transparency. Transparency solution are transparent, which means we can see through this solution. Colloidal solution are translucent, which means not completely opaque, not completely transparent. That is what we call as translucent. Halfly transparent, halfly opaque, that is translucent. Translucent, if you take a glass of water and add a few drops of milk in it and stir it, the kind of solution you can see, that is translucent solution only. After that, we have suspension, that is opaque, which means from suspension you cannot see the things. That is opaque. But what we call opaque, if we cannot see through this, if I have this cardboard sheet, I cannot see through the sheet, so this is opaque. Transparent, we all know what is transparent. If we see through the object is called transparent. That is all transparency about true solution, colloidal solution, and suspension. So this is all about the three solution, colloidal solution, and suspension. This is the all about properties of three mixture in nutshell. So here we have seen that difference, or we can say comparison between this solution, suspension, and colloids. We have to remember properties of all three and example of this commonly used colloids and the type and its dispersing phase and disperse medium. So this is about what we called as mixture of different kind. In the next session, we will see our next topic, important topic, that is separating the components of mixture. Now we have already seen that from which this mixture are formed, what is the nature of mixture. Now we will look into how we can separate these particles of mixture like solution or colloidal solution or suspension. We will see basic techniques of separating the components of mixture. So that we will see from next chapter, next lesson, that is our important and next part of this chapter. So I hope you will got the point of what is solution, suspension, and colloidal solution.